us later. Next up is a session that's about Conda. I guess the instructors seem like they're here in the room, so you can start appearing.
Stop my video.
So this session, so you may know of Conda as a way to install Python packages, but it's a lot more than that. It's also a way to install R packages and other compiled code kind of stuff. And we have a running joke in our garage session. It's days
Okay, now you're
since...
just doing my intro.
Okay. Well,
Okay,
I'll let you
ahead,
do your intro then.
Yeah. I mean, fine.
Okay.
Yeah, we have the running joke, like days since there was a Conda question in the garage.
Yeah.
Okay, how was I
And
going
it's
to go
always
into that?
0.
Yeah, it is
But
always
anyway,
0.
but that means two things. One, Conda's pretty important for installing software because it's the best way to manage Python and compile the scientific software on a cluster. And two, it's harder than it should be. Or maybe it's as hard as it needs to be. It's just that it's actually a hard problem. So us as cluster admins before the RSE things started, we, like, the software installation probably took up most of our time. And yeah, so where was this going? Yeah, software installation is quite a difficult thing. And now, lucky you get to learn one way of handling it. So maybe I'll just go and let Jarno and you do their introduction. So see you later.
Right.
Bye.
Yeah. So, I mean, my my starting intro was going to be that joke specifically. So, like, yeah, days since we've had a question about Conda is always 0 because Conda is very useful, and you also run into complicated problems. But if you then include the kinds of questions where it's about installing some software or problems installing some software, and the solution is Conda, you get even more of those questions. There's basically like a half of the questions or something like that. So yeah, what is Conda? Because the name of this page that I'm sharing is Python environments with Conda, and that's also linked to in the notes page. But Conda is not just about Python installations. It's a very general dependency manager. So to install a specific piece of software, you have a bunch of dependencies that need to be installed as well. So this could be like system, like what would normally on your own desktop laptop be system libraries and specific versions of those system libraries. You can install those with Conda and then get the software to work. And it's also useful for separating between projects, because different projects might need a different version of some library. Often they're not designed to exist at the same time, but Conda takes care of that as well. So it is very useful. It also does have some problems, especially when used with Python on some HPC systems. So we'll come to that later. But yeah, I guess one important point about HPC specifically is that it's always a shared system. So installing all the software that everybody using it needs on the system level would get very complicated very quickly. And that's where Conda helps. It allows you to install software that that you need, that maybe not everybody else needs. Okay. I mean, I did not introduce myself or you. Do you want to introduce yourself?
Yeah, my name is Yu Tian. I'm also one of the RSEs. I'm very happy to be here today. Yeah.
And I'm Jarno. I'm also an RSE in here in Aalto. Okay, so let's get started. So yeah, I mean, Conda is actually language agnostic. There's nothing specific to Python. We use it often to handle Python environments. An environment actually is so an environment is when you have this certain set of dependencies for a specific project, and you can have a different environment for a different project. So you can have a completely different set of libraries for a different project. So it's a very general solution for handling software environments. And actually, yeah, we use Mamba most of the time. Mamba is a replacement for Conda that's just faster. It uses a different algorithm on the background. But it's essentially the same thing, a very small difference. So let's actually go to the terminal and get started. And there's some, well, we load a module called Mamba. Module is its own kind of, it's a system level way of handling the fact that people need different software. There will be a separate section on the module system later in this course. So I will not explain that much of it, except that I will show you. If I try to run Mamba, it does not exist. I am on Triton. We do have Mambas, but I do need to run module load Mamba in order to get access to it. And now I have Mamba. Oh, it printed a long list of commands you can run, but it did work. So the command is found. And then we have this initial setup. This is very much Aldo specific. It's something you probably should not run on other systems, but it's here in the documentation. And if you are on Triton, you should run it. So if you're not on Triton, ask, and probably don't just take like our Aldo instruction or Triton instructions directly. Okay, and that's the first time setup. Oh, there was one thing I was going to talk about before going to an example here. So about Conda channels. Channels are where Conda pulls the software. So they store a bunch of these libraries, binary packages, and allow you to install them into your environment. So there are many options. Conda Forge is probably the biggest one, and you almost always want to include it. It has a lot of packages, and it's well, the licensing is good for research. It's mostly open source, and the channel itself is open source, so it's very useful. There's also the defaults channel, which is maintained by Anaconda Inc., who also maintains the Conda command itself. There's licensing issues though, so you mostly want to exclude it. And if you do want to include it, it's a specific case and you know what you're doing. Okay, there's also Bioconda, for example. Okay, Bioconda has specifically bioinformatics packages. It's a separate place for those. And if you are in bioinformatics, then you will often end up using it. PyTorch, the channel doesn't exist anymore, and I should have deleted that line, but I didn't notice that it was there. So we will demonstrate installing PyTorch for machine learning later from Conda Forge. Okay. So I will do a quick example of creating an environment with R, because this page is about Python, but you can also install R and R packages there. Or any questions? Anything before we delve in?
I have a question actually.
Yeah.
How to exclude the defaults from the channel? From the Conda config or from the YAML file?
I always use the YAML files, and I guess well, let's make a YAML file.
Yes.
I mean, so yeah, I always use the YAML files instead of the config because the file essentially you can have it with the code and with the whatever version that you've been running that has produced a specific result, like you can include it with your paper basically. So
Yes.
Everybody can reproduce the same thing.
Yeah, so if you push it to a Git repo, it will be there.
Yeah.
Then everyone can reproduce.
Yeah.
That's good.
Yeah, was there anything else about the about environments and managing software in general? Guess we can come back to any questions if there's there. Left side of my terminal is slightly off screen. So now it should be on the screen, I think. Okay. Okay. So in order to create an environment, and my workflow I generally recommend is to create a YAML file. So I use Vim to edit the file. You can use Nano or whichever you want. I'm creating a file called tidyverse.yml or YAML, and this will describe the entire software environment for my project. So first, name for the environment, and I will call it tidyverse. Tidyverse is an R package or an R, well, it is a single package, but it contains a lot of useful things. Then I will describe the channels. So this is a list of channels that Mamba or Conda is allowed to use to construct this environment. I will say Conda Forge. Whoop. That's the only one I need for this one. Okay. And then dependencies. So this is the list of software we actually need. And I will only specify one, R tidyverse. So because this R tidyverse depends on R, we will also get R, the entire programming language ecosystem, into this environment, and it will automatically have a version that supports whatever version of R tidyverse it pulls up. You could specify a specific version of it. I don't actually know what versions exist though, so let me not just do that. Okay, and then I'm saving the file. So just to have it on the screen, let's cat it. So this is what the file looks like, although very quickly it will actually disappear off the screen when I run the next command. So we can do Mamba. I actually did not write down the command, so let's see if I get it right. Mamba env for environment, create -f, f stands for file, and tidyverse. Okay. So now it's looking for first tidyverse in Conda Forge, and then it looks for possible dependencies. It's taking a while before printing it. Okay, here we go. So it found a bunch of stuff. If I had one more character width on the display, it wouldn't break the lines, but that's fine. So yeah, it takes a while to download all of this. Tidyverse is relatively small, so it doesn't take that long. That's why I chose it. But it takes a while to get all of these system libraries like Xorg, the window manager, or the graphic. Well, it's window manager, graphics manager, display manager for Linux, and a lot of other stuff. Font config and GNU, C libraries, all sorts of stuff. Okay. So it is essentially constructing an entire software environment. Let me. Oh, okay, it's done. Then I will not yet take a look at the notes.
Hey, yeah,
So,
there's a question asking us to clean the terminal so that they can see the commands on top. So maybe move the terminal a bit upper or clean the terminal.
So I guess, does it mean that they cannot see the lowest line?
Yes, I think that's the problem.
Okay, can move it up a little bit. Maybe that's it.
Maybe run clear.
So I want to comment on the text that
Yeah.
it's showing here. So because in a lot of systems, you actually do not want to run this command. On Triton, you do not want to run this command. So instead, we use source activate tidyverse. But okay, let me clear the terminal first. The reason that we don't want to run this command is that it requires you to modify the shell environment in some way. You need to run this Mamba init command. It will tell you to run it if you run this Mamba activate. So we want to avoid that, to avoid complicating things even more. So instead we run not Mamba activate, but source activate tidyverse. Okay. So now it's showing that this particular environment is active. And since I have it active now, I have, for example, the rscript command. So let's make a hello tidy.r, an R script. If I was using a graphical system, I could also run RStudio, for example. Okay, I'm not going to explain that much about what is happening in the script, but maybe I should say it will check if I actually have tidyverse, and then it will tell me, and it will say tidyverse could not be loaded, or dplyr could not be loaded. So I can use rscript to run hello tidy, and it should report that the tidyverse library is available. Okay, there were some conflicts that became errors. It loaded successfully though. I do not know enough about R to actually know if this is a problem or not. Probably not a huge problem. Okay. So yeah, that's the point of this demonstration though is to show you how to record the dependencies in a YAML file, and also to show you that this is not just for Python, that you can do, you can install a lot of other things as well. The next thing though will be Python, because it will be how to set up an environment for a large language model. How are we doing on time? Not bad. Okay, so next I have a section about why you should track dependencies, which we actually did touch on a little bit. So maybe at this point, do we have any questions in the notes? Or do you have other questions just in general?
There's a question about how do I exit the environment tab when I think that's asking about the deactivation.
Yes. So now I still have the tidyverse environment active, and that means I do have, for example, rscript. Version of rscript is yes. So to exit, I could run source deactivate. Okay. It will complain about the source activate, source deactivate thing. But I do not want to change the environment to run Mamba activate and Mamba deactivate. So this is fine. Now if I try to run rscript version, it will not find rscript. So now I'm outside the environment. I don't have R anymore, and I don't have the libraries. Okay.
Okay, there's another question about is Conda like a Python 3 inf? I suppose it's asking the Python's own virtual inf and how it's different from Conda.
Yeah, so also I guess like venv or venv comes with Python 3.
Yeah, I think
so there's plenty of different environment managers. The Python 3 venv thing is designed for Python specifically. It can install Python packages. So it cannot install system level packages. And it cannot install R for you. So Conda is more general. It's not just for Python, and it can install some system level things. So, for example, we'll soon install an environment that has CUDA in it, without you needing to set it up for your system in the same way.
Yeah, I think maybe it's the time to go to the next step.
Yeah. So, but there is also a question about the CSC thing. So, in a lot of the background of this is that Conda creates a lot of files in the environment, especially if you install Python packages. It can be millions of files, and this is often bad on an HPC system. So, if you want to use Conda to manage environments, there is this solution from CSC called Tykky, the container wrapper. So it can create something very much like a Conda environment for you. It is actually a Conda environment, but wrapped into a single file that is a container. So you can read up about it in here. And yes, there is a link to it already in the notes. So most of the things I say apply, but the commands are different. And this is probably true on a lot of systems. So yeah, if you're using a different system, you do need to figure out how to do this in your system. Maybe there is even a different manager. Okay. But yeah, so let's move on. Okay. So we already mentioned, talked about how using a Conda environment, so using a file like this inside your code, makes your code and your research more reproducible. So you can track the entire environment, your entire coding environment in a single file. And then you can include it either with your code or with your data, for example. So if you publish a bunch of data, you can include some software to analyze the data, and you can include a file that describes the entire environment that you use to analyze the data, so that it is way more reproducible. People can install your environment and run your code and get the results from your data. It also helps with debugging, so you will get a lot less of the "it works on my machine" problem when other people can reproduce the same environment that you have. And it allows version controlling. So if you are doing some heavy software development, you are hopefully using version control with your software. And you can also version your environments. So you can create different versions for different versions of the software. So it's very useful for yourself. It is very useful for helping your teammates, your people in your research group, set up the same environment and run the same code. So you can give them the file and give them these 2-3 commands, and they will have the same software environment as you do. It also works across different operating systems with some caveats. So Windows might require different versions of system libraries, but if you don't specify exact versions, it will mostly figure out how to use the correct ones. Yes. So it also helps with a lot of these Python dependency problems, and especially problems where you need multiple different versions of the same package for different versions of your software, different projects. So those are the main points for why to use Conda in general, or why to use why to use software environments in general. It becomes very it becomes an especially useful thing if you have multiple projects running at the same time with different code. Okay, so there's one more thing that I want to mention about practically how to use this. So we have it somewhere. There are some a list of useful commands that I could also demonstrate while we go. So I still have Mamba, and now that I have an environment, I can run. I was not in an environment. I exited the main. So okay, if you are in an environment, you can list. So let's activate the environment. Tidyverse, source activate tidyverse, and let's try. So you can list all of the packages that are in the environment for additional reproducibility to make it extra clear what's in, and then to check to do some debugging on what is installed in your system, in your environment. Okay, you can also remove an environment, but really which is necessary and useful occasionally. Cleaning the cache is necessary if you run out of disk space. But the main thing, the big that I want to highlight is how to update an environment. So you can install a package directly into the environment that already exists. But what I would do essentially always is I have this tidyverse.yml file, is to edit the file. So what should I add? I have R already, but I can add it explicitly as a dependency, and I could specify a version, for example. So let's see. So now I can run Mamba env update, and then use -f or -- file and the environment file. So let's see if it works when I specify the R. I did not specify a R version. I just specified that I want R. It did install some new packages, which is interesting. Maybe I didn't have the R command specifically before. I just had R script. Okay. So you can update the environment. You can add new packages to the environment and keep track of them in the file as you go, which makes it makes the file more useful in the long run. Okay. So here's about setting default channels, and like I said, I always use the YAML file to track the channels, but you can set default channels in your Conda RC file or in your Conda configuration, and that can also be useful. Okay, and that's the motivation for using Conda section, which essentially we already talked about. So yes. And a section about how to set up an environment with CUDA, which we'll be talking about next. But essentially, I will do this by not that much looking at the documentation, which you can read yourself, but rather by just creating a new environment. So let's see how it goes. So let's create a new environment file. And this time I want to develop some language models, large language models with Python and PyTorch. So to do that, I will create a new environment. Let's call it PyTorch.yml. And again, the environment needs a name. So I'll call it PyTorch. And we'll need to list some channels. So now we want NVIDIA as one of the channels because this environment will depend on CUDA, and that comes from the NVIDIA channel. Or some CUDA-related packages come from there. We'll also want to use Conda Forge. That is almost always there. and then list the dependencies. It is correct, I think. Yes. Okay. We will definitely need Python, and I want to specify the version of Python, because if you it's actually missing a dash here, a minus sign there. So if you don't specify, it will probably, well, it will first of all try to check all different Python versions for possible PyTorch packages, and that will take a long time. Not as long as installing PyTorch, but still. So that's one reason, but also it will probably actually try Python 3.13 and then just fail because I think some of the packages don't exist for Python 3.13. I'm not sure why it doesn't figure that out before it tries to install, but there's something there, some configuration issue somewhere there in the packages. Might actually be useful to just demonstrate what a failure looks like, right?
Yeah.
Okay, well, actually, that will come. So let's see. So we want PyTorch GPU, and I'll just specify larger than 2.6, less than 2.7. Mostly just to show the syntax, but also because I don't remember the exact version. I didn't write it down in the notes on purpose. So Torch Vision. This is often useful if you are dealing with image models. Let's do Torch Audio as well. Just commonly installed in a PyTorch environment, although if I'm using large language models, maybe I don't need them. But I do need definitely is transformers. Okay, so there's some useful packages for machine learning stuff. And let's save this file and show what's in there. Okay, and then so let's see how long it takes to construct the environment. So Mamba env create and use the PyTorch file. So the first thing it does, it recognizes that I'm on a Linux system. It can also use no arc version, so no architecture or system independent packages. And then it's looking for specifically system packages and dependencies that work on Linux to get all of these dependencies. Okay, so we have a critical issue. I almost transitioned to the notes, but not quite. So the problem here is that it doesn't find CUDA. And it doesn't find CUDA, and because we don't actually have any GPUs on the login node. So there are nodes on Triton that have GPUs, but on almost any HPC system, you're not going to have GPUs on the login node. So that is confusing Mamba here, and it's thinking that you're trying to install some GPU-dependent stuff on a system that doesn't have them. I mean, technically, it is correct about that, but I still do want to install this environment that depends on GPUs existing in the system. So we can override the CUDA version and just tell it that we have CUDA 12.6. So that is also mentioned here in the notes. Yeah. So we export that and then we try again. So Mamba env create pytorch.yml. Okay, so this version of the command worked yesterday, so we'll see. It's always possible that some library got updated and broken somehow. But while we wait, let's see if there's any other interesting questions in the notes or important questions. What are the channels? So yeah, I guess we went over this maybe a bit too quickly. But yeah, channels are repositories of packages. So they are servers somewhere that store all the packages that you might need. Well, all the packages that somebody has added to them. So Conda Forge is one of them, and it says it contains a lot of different packages that most things depend on. So Conda Forge includes torch vision here. I think transformers also comes from Conda Forge. Does anything actually, there's also the NVIDIA channel that we included. So does anything actually come from there? Yes. So some libraries that have to do with CUDA and with NVIDIA GPU specifically are coming from the NVIDIA channel. So Conda Forge is the big channel that has a lot of open source packages, and most stuff comes from there. But NVIDIA has things that NVIDIA maintains. So this is a channel where NVIDIA provides a bunch of packages, and it's necessary for this environment. Okay, so let's run this to install the environment. And this will take a while. It should succeed, but the main point, though, is how to create the environment and how to use it, and not actually finishing this this download process where it gets all of the PyTorch and all of the system stuff. But yeah, so it is actually now downloading this from the Conda Forge server. So the channel is where it's actually pulling all of these dependencies.
But if you have something cached, will it be faster?
Yes,
Like,
definitely, yeah.
If you have a similar environment installed before, then it will be faster, right?
Yeah, and I think it will even slightly prefer cached versions if they exist, but also quite often when you create one environment and then you create another one with almost the same requirements, it will still end up using slightly different versions and re-download stuff. But yeah, in principle, it does cache the packages. I think it also does some fancy system or fancy linking where it actually uses the same files in different environments if it just has the exact same version of a package. Okay, I think it's almost done. And so is also our time. So unless there's anything else, I guess we could move on to a break. I mean, showing that it works is kind of fun, but not necessarily worth the wait. So what is next on the schedule?
I think it's a break or
Yes. Hello.
Yeah, we have a short break, and then we get back to hands-on with, I think it's array jobs, which is the start of parallelism and the power of the cluster.
Okay.
So
I'll stick around and answer questions, of course. There's a number of questions coming up, so just keep them coming.
Yeah.
And
so I guess
see you around.
I guess we have a break until 2 minutes past the hour. So yes, there it is. See you later. Bye.
All right. See you. Bye.